Look closely at your kitchen counter. The physical world isn't sitting still. It's constantly changing, melting right in front of us, taking on new shapes. But we can organize all this daily chaos into two simple buckets. There are changes that can easily go back and forth, and changes that are strictly a one-way trip. Take that puddle of water. If you put it back in the freezer, it turns right back into solid ice. The transformation takes a step forward and then easily takes a step back. Now try that with a piece of burning paper. Once it turns to ash and smoke, you can wait as long as you want. That ash is never going to turn back into paper. A fried egg doesn't unfry. Firewood doesn't unburn. These belong to that strict one-way family of transformations. Watching whether a material can easily undo itself reveals exactly what kind of physical event you are looking at. When a change is easily reversible, the core material hasn't actually gone anywhere. It just swapped its physical state, like moving from a solid to a liquid to a gas. Think of ice, the water in your glass, and steam. They're the same stuff, just water wearing 3 different outfits. But one-way trips are deeper. The original material is destroyed, and something entirely new takes place. Ash is its own material, with its own color, smell, and behavior, far removed from the paper that started the fire. This shifts how you look at a simple campfire. You aren't just heating up wood. You are watching the wood cease to exist right in front of your eyes, as brand new materials are born. Chemistry centers on one specific question. Did a brand new material just appear? Once you start asking that, you stop seeing a fire as a simple spectacle and start seeing it as a process. Which brings us to a classic childhood mystery. When you hang wet clothes on a line to dry in the sun, where exactly does that missing water go? It certainly didn't vanish. The water simply left the fabric and spread out into the air around it, floating away as an invisible gas. We actually rely on this exact same process on a massive scale. By letting vast pools of seawater evaporate, we can harvest resources. The heat from the sun pulls the water up into the atmosphere, leaving nothing but mountains of solid salt behind on the ground. Back in the kitchen, a boiling pressure cooker does the exact same thing. The heated water builds up and finds a way out through the valve, escaping our view without actually ceasing to exist. The exact same logic applies to a gas stove or a burning log. A pile of ash weighs much less than the original firewood because the missing weight floated up the chimney as smoke and hot gas. Here is the ultimate rule of the physical world. If you trap all the leftover ash, the invisible smoke, and the air used to burn it, and put it on a scale, it would weigh exactly the same as the starting log. Matter never simply vanishes. Once you realize that, you stop accepting vague explanations and start demanding a strict accounting of where every piece of the material world actually goes. We can apply this exact same accounting rule to the most stubborn material in our modern lives: plastic waste. A plastic bag left on the beach might look like it disappears over time, but sun and ocean waves just break it into microscopic fragments, microplastics, that stay right in the ecosystem. Knowing matter never disappears gives us the power to fix it. Recycling means taking control, melting it down, and giving it a specific destination. But that brings up a new mystery. None of these changes, melting an ice cube, burning a log, or melting a plastic bottle, happen for free. This diagram shows the hidden driver pushing all of this along. It travels from the heat of the sun down into the plants we eat and finally powers your own movement. Tracking where the physical matter goes is a great start, but tracking the invisible energy that forces that matter to change, that is the next great step in our investigation.